So since we kind of skipped the slides, I'm going to hit these real quick just because this will help you as we go, because I throw out the cloudy terms and whatnot. I like to always cover these as we go. So we'll talk about images. Those are files on the disk. They're basically the entire operating system at rest written out to disk. They live in their own little database, as it were. But you actually boot up an image to create an instance. And so the instance is the running server. So you can think of the instance like you would a laptop, only that at the end of the day you're going to destroy an instance. An instance is full-fledged server. It's a fully contained running server on the cloud. The different running states. So running, everything's up and running. Suspended, you think about the same way you think about your about shutting the lid on your laptop. Everything's in memory, everything's preserved, it's ready to wake up fairly quickly, as opposed to stop, which is literally like turning off your laptop. You know, everything is out of RAM, but everything's still preserved on disk. It's still sitting there ready to use. And then you have shelved, which is a little different. Shelved would literally be you're stopping it, you're shutting it down, and then you're disconnecting any connections and putting it on a shelf. And the difference between those really comes down to these two still are pretty well active and ready to go. They're sitting on the hypervisor, which is the term on the next page, and are still sitting there ready to go. Shelving is actually literally putting it back in the image library for use later on. So you're freeing up the resources. There we go. So more cloud computing terms, flavor, the size of the running instance, so that's defined in cores and RAM and disk. The hypervisor that I mentioned before it's the hardware that the instance is running on. So it's the compute node for all intents and purposes.
Now what happens if, say you're using a Jetstream instance and you're in an interactive session, and you wander away for a while, and you get timed out, and save everything in your last.
You don't time out, okay. Unless your allocation runs out of allocation. Now, if that happens, if you completely run out of allocation, you get shelved. But if you wander away and it's not like a traditional login connection where you connect to an HPC service, and if you're idle for an hour or two, it logs you out. That VM will stay running until you stop it, or until you run out of allocation.
Okay, so don't leave it running over the weekend.
Well, if it's doing something, sure. I mean, by all means, leave it running. If it's idle, you're wasting your own allocation. It's not really hurting anything. I mean, you're taking resources that other people could use, but at this point in time, we're not 100% filled, so it's not a huge issue. But you're just hurting yourself. It is a good idea to always put it to sleep, basically. And the difference is, because people always talk about, the differences between these, why would you do these various things? And my rule of thumb always comes down to this. If I'm going to be away for a few hours, I'll just leave it running, because it's just not worth my time to stop it and bring it back. Depending on the size of your VM, I tend to work on mediums or smaller. So 6 cores, per, basically 6 SUs an hour is not a whole lot. People that are using like the 44 cores may feel a little bit differently about the whole situation. But if I'm just going to be away a couple hours, I tend to leave it running. Now, if I'm going to be away overnight, I'll suspend it usually, which still burns SUs, but it's only 3/4 of an SU. So it's less, but that way it comes back much more quickly. Stopping, I'll do if I know I'm going to be away for multiple days, but I'm still going to come back to it maybe that week, or maybe I stop it on a Friday and come back to it on a Monday. That uses half an SU. But if I know I'm going to put something away and not be back to it for a while, I shelve it. Okay. And the shelving it's the best thing to do for your own allocation, but it also frees up the compute node. So if you have, for instance, that 44 core running, and you shelve or stop, you have held up that entire node that nobody else can use. So when you shelve it, you actually write yourself out to disk and are completely removed from the node. So you freed up that hardware for somebody else. So it's the kindest thing to do for yourself and for others, but it really, to me, just depends on how long you're going to be away. Some people have taken to shelving every time because they don't want to eat their allocation being idle, and I get that. But to me, my time is worth something. So I tend to think about suspending or shelving. To be honest, I almost never suspend. I usually stop.
Or if you're using it for class, you don't want to spend the first 5 minutes setting your instance up.
Yeah, exactly. So those are some of the different sort of reasons why you would do that.
And as of October 1st, the revised service unit charge rate for suspended, stopped, and shelved instances
You're reading the banner that just came up.
has changed. So
You're unique.
there's also that.
Yes.
You read.
That's actually why people have started shelving more and more, is because we have started charging for the stopped and suspended. And the reasons for that, well, one is to get people to be more mindful of what the resources they're using. But the other side is it also wasn't reflecting our true usage and capacity. So when we're reporting to DNSF, it's like, it's under-reporting how much of the system is utilized. Because they're not actually, we were only referring to it as burned SUs. So if people had a bunch of instances that were stopped and suspended that were holding up compute resources, well, those should count for us. So that was another part of the equation. But it was also more future planning of people that are holding up resources should get charged for those resources even if they're not in use, because they're holding it up.
Right.
Yeah, so anyway. So we covered flavor and hypervisor. Snapshot. So Snapshot is a little different on the atmosphere side. That's more of an OpenStack reference, but it's the same idea of taking a picture of your VM state, and that takes a picture of the disk, nothing else. So you've installed a bunch of software and you want to be able to replicate it over and over again. You take a snapshot, create an image, is how we refer to it on the atmosphere side. And that way you can launch it again and again and again as it is. So you don't have to recreate your workflows every time. And then state is something worth remembering, the state of the system. So is it running, is it stopped, is it suspended, is it active? It just tells you what the state of things are. So here comes down into the persistent and ephemeral stuff that George was talking about earlier. And this is something that I try to hammer into people during the slides and then also here. So I'm going to skip down to the two bottom pieces. So persistent storage and ephemeral storage. So ephemeral storage, by its very definition, will go away. We think of the storage that is built into a VM. So if you've launched a VM with a 60 gig disk, that 60 gig is ephemeral storage. You delete that VM, it's gone. No getting it back, it's never coming home again, it's gone. So you think about anything you place there, you have to expect could disappear. VM accidents do happen. People accidentally do all sorts of silly things to VMs, and occasionally there's system issues where a VM might get lost. It's happened before. They are rare, but it has happened. Whereas persistent storage is storage that you expect to stick around. And we think of that as our volume storage. And the difference between the two is that volumes can be hooked up to different VMs. So you delete a VM, but the volume doesn't go away. So that volume can be used over and over and over again. It's more persistent. There's also a little bit of difference in how it's maintained behind the scenes. The replication that's done for the persistent storage versus ephemeral storage. Both are safe, both are redundant. We can, in theory, use an entire shelf of disks and the user will not see any issues. That said, we don't want anybody to lose their data. So we always advise people use volumes for your persistent data, for data you can't afford to lose. And beyond that, and I nail this again and again and again during the hands-on part, is always maintain multiple backups. If it's data you can't afford to lose, if your entire dissertation is sitting there, you can never have too many backup copies. So we've never lost a volume, but we also don't want anybody to be the first case either and basically watch their research go away. So always good to consider those. The other part of those are object store and block store. So block store is what most people think of for the storage. So it's volumes. You can think of it like connecting a flash drive or an external drive. It's a drive that looks like a logical part of your operating system, and it's a block device. So it looks like a hard drive to you, it acts like a hard drive to you. Object store is a little different. So you basically have a starting point and some metadata about it and a size, and it tells you basically here's my storage here, it doesn't look like a disk. You don't address it as a disk drive, you don't address it as a mount point. You actually use a client that understands the object store and go retrieve it. Most people, when they think of object store as S3, if you've ever used Amazon's S3 at all, okay. But that's an object store type of use, and it's very different for most people, and a lot of people are not using it like that. We're starting to see more and more people using it because it becomes very efficient for their usage.
So is it like a cache memory?
No, it's basically, it's still, you know, either spinning disk or SSDs, whatever. It doesn't really matter what's underneath it. But it's basically, instead of being organized in the way a block device is organized, where you write stuff out and it's, you know, basically here it is. This is actually sitting in a large data store. You don't mount it, you just stream the data in and out. So it's the difference in access, I guess, would be the way to think about it.
Okay. So like if we like analyze it in terms of like CPU, so it could be a cache memory, but in terms of speed of retrieving it.
Yeah, I guess. I mean, the speed is really determined by what's backing it, more than anything else. It's not inherently faster or better than block store. It's just different.
Okay.
It does reduce the dependence on making sure things are mounted and having file systems. If you think about the POSIX compliance, it reduces. So with POSIX, like what people think about with Unix file systems, there's some inherent limitations to it. I mean, part of it is locking, part of it is performance, part of it is depending on what file, depending on what's underneath it, you have some performance issues. Like Lustre, for instance, doesn't deal with small files well. So if you're doing ls minus LA on small files and you watch your system come to a grinding halt, this kind of takes a different approach to access. So I would say better at multiple access and better at streaming things in and out. George, would you say that's pretty fair?
I'm sorry.
From an aspect of object store versus block store, of the method of access is really the biggest difference of streaming it in and out versus writing to a block device and having the POSIX issues that you have with writing to a device.
Yes, I would describe that a little bit differently in the sense of what I was talking with Amy about earlier. You know, doing it the cloudy way, using an object store is the cloudy way. People are used to having a file where they open a file, they seek to an address, they read or they write. There's this hierarchy of, you know, I have a root, I CD into a directory or whatever. That's a file system, okay? An object store is a blob of bits. You have a starting address and you have a sock, essentially. And so the way you use an object store is you stream it. Okay, a lot of times your object store is just a URL. It's HTTPS
Giant
colon
string of
and
things.
some great big
Yeah.
name. Okay, and so what you do is you open that up and these bits start flowing in to standard input if you're a programmer. Okay, so it's up to you to interpret that stream of bits. If it's a tar file, you pipe it into tar and you break it out and throw it on a file system. If it's data, you know, the first 10 bytes are the date time, the next 10 bytes are the temperature, and it's up to you to interpret that flow of data. It's not a file, it's a file.
You just lose some of the inherent weaknesses of a traditional file system. You don't have the access issues, you don't have a lot of the locking contention, you don't have a lot of the general things that where traditional file systems break down, object stores kind of work around it.
So
Sort of.
I think like it would help more in like input-output operations.
I would say simpler input-output
Simpler.
operations.
You can do input and output to
That's
an
it.
open file. You can't, there's not the same concept. Okay, because you can't like read to a certain section in the
Right.
file, read it in, and then write back out the change differences like in a text editor. Okay, so you can stream it in or you can stream it out. And you can add to the end of it. You can append to it, but you can't like change the middle of it. Okay.
So when you make a change, you're actually writing a new object out.
Yes.
Yes.
And coming back to the cloudy way of doing things also, a file system is very expensive. You've got the overhead of the metadata and all this other stuff to create the file system. It's very cheap to just have a blob of bits. Okay? And then when you're storing that on some kind of storage device, you get into the replication of the data. And things like that.
And you also can have, one of the nice things that Object Store does is it will let you do version control fairly easily in a bad way. I mean, it's not a version control system, but it's, you stream in a blob of bits, you make changes and write out a new blob of bits, you still have both blobs of bits, so you can always refer to either one. It's not a true version control system, but it's a way to have protection of, I've streamed in this data, I've written out this data, my original data still sits there. So it kind of keeps you from shooting yourself in the foot if you use it right. So this is what I call the 40,000 foot view of OpenStack, and we're going to be doing this today. So this is what's underneath Atmosphere. There will not be a quiz on this. Okay, there might be a quiz for Amy on this. But this is basically what happens, and I am going to walk in front of the screen at this point. So your client comes in, and so you're going to be coming in through Atmosphere. You're going to log in, and so that login is going to talk to Keystone, which is the OpenStack authentication service. It's going to pass you back a token saying you're allowed in and this is what you can do. Your client then, when you want to go launch something, will talk to Nova. And Nova will come along with its scheduler, and basically it'll say, I need the image, so I get it from Glance. I need some disk to put that image on depending on the size of the flavor I'm running. So I'll grab, Seth will give me some disk to run that on. And then Cinder will actually go through and allocate that disk for Nova to use. So it puts all those bits together and throws you onto a compute node with a running instance. That is the way, way oversimplification of what's happening. But it kind of gives you an idea of, this is there are a lot of moving parts underneath going on to bring a VM. So we're going to see the really easy part of, we're going to choose a few options and press a button to go. But this is the very, very simple version of what's happening behind the scenes. Any questions before we kind of get to the fun part? Maybe you're debating whether this is the fun part, right?
Yeah.
Okay.
It's all fun.
So go to the usejetstream-cloud.org address, and you were the only one that needed a login slip. George, you don't need a login slip, right?
Good.
I'm going to use a login just because that way I see exactly what you see, because my account sees a few other things. Is everybody there?
Uh-huh.
Okay. Well, then I'm going to get there as well. Bear with me 1 second. All right, so here we are. We are at Jetstream. So this is what you see before you log in. You get the image library, and we let people see this on purpose because we want it to be sort of a teaser of here are some of the things you can do. So you can kind of scroll through and see all the images, and there are a lot of images. I mean, at present check, I think there are roughly 1,000 active images. But this is where you start out. So first thing we're going to do, if you haven't already, is click in the upper right and click Login. And that's going to take us to our login page. There we go. So when you hit this page, you notice that you've now been branded with the Exceed information, and you see a thing up here called Globus. And there are a couple things going on here. So Jetstream has absolutely no usernames and passwords stored on it. We don't keep any of that information, and I like it that way. It's fantastic. We don't have to worry about it. What we do is we authenticate using Globus via Exceed. So we use our Exceed credentials to log in. Once you've actually gotten a Globus ID in Exceed, you can actually use some of the things that Globus is federated with to log in and use your credentials there. So for instance, I can actually log in using my account to the Indiana University, using Indiana University, my credentials there. And that gets me my two-factor authentication there. You have to link your credentials to actually do that, but it gives you a lot of flexibility for using your login credentials. You can even use your Google creds once you've linked that to your Exceed account, to your Globus account. So for today, though, we're going to use Exceed accounts, and that's the account on the little slip here. and that's going to let us in to use Jetstream. So make sure it still says exceed in the middle and hit continue. And we put in our exceed username and password. And this is where, if I had chosen to use Indiana, for instance, this would actually come up to my Indiana credentialing page. So we're actually logging in through exceed. So train 52 and this horrible password. I don't set these passwords, by the way, so this is not my fault. And we should log in. If you're logging in for the first time, you would also get a do you accept these terms, which is basically the exceed terms of service, basically saying you're going to use it for academic research, academic purposes, you're not going to do horrible things with it, and that you are legally allowed to use it, etc. So I'm going to get rid of that little banner. So we're logged in. Everybody logged in? Excellent. So this is what you see when you first log in. You get the Jetstream dashboard. So you have the three big buttons. These are probably the most important things that most people want to see. Launch an instance, get help, and then change your settings. If you scroll down a little bit, you can actually see your resources, so you can see your allocation. So everything in Jetstream is controlled by an exceed allocation. So to use the system, you have to have a valid exceed allocation. That can be a campus champion allocation, that can be a trial allocation, it can be a startup allocation or research allocation. But you have to be on an allocation. So this will actually show you the allocation or allocations you're on and how much of it's used. And to give you sort of a comparison, I'll show you my account where I have multiple, not my Facebook page. And you can see here's the allocations I'm on and the various rates of use, and you can see two of these are actually expended and no longer work, but it kind of gives you a different view of the allocations that are there. So this particular training account is on the one allocation. Again, over on the side you can see the number of instances you have running, and there are none, but here's mine. I have 12 instances running, 6 that are shelved, 6 that are active. I have 3 available volumes, so you can kind of see that there. You can see the resources that are in use. So on IU, I've got, well, that's fractionally wrong, but I've got 36 CPUs in use, 96 gig of RAM in use, 24% of my storage is in use, and 3 of my 10 volumes in use. So if I had anything running on TAC, that would actually be what that 0 is, would show me there as well. So you can kind of see at a glance what you have in use. And then you can also see a history. So you can see the things I've launched and when. You can see what, when they were launched. You can actually see what they were, and you can click on those and see them. If they're still active, you can actually click on and go into one and see it running. But I'm going to go back to our training account. The training accounts are just kind of boring because they get reset all the time, so you don't get to see all the history, and there's never anything running, or there shouldn't be anything running. So if you see anything other than 0 here right now, well, if you're running on your own account, that's one thing, but for a training account, that should always be 0 when you log in. So just kind of boring. So I wanted to show you mine and kind of see a little different look. The next thing I want to do, though, however, is take a look at the settings. So you come in, you've gotten your account, and you probably want to do a few things, a little housework before you start using it. Now, most people think the first thing they do is they launch an instance, but we're going to go through and pretend that we're going to explore a little bit first. So the first thing is you see receive an email notification when an instance finishes. That's a completely optional thing. I particularly like it just because I tend to launch an instance and then wander off and do something else. And so getting the notification when it's ready and to remind me to come do it is good. That's completely up to you. Doesn't make a difference either way. Requesting resources. This is only for requesting CPU and RAM, basically. If you actually need more allocation, that's a different mechanism, and we'll talk about that a little bit. But if you find yourself hitting a quota, you can't launch another instance because you're out of cores, you can request more, and it'll ask what you need, and it'll make you justify it, and then we'll talk to you and see if it's really something you need or if there's something else afoot. Icons. This is, again, just for fun. These are randomly generated at every boot. The best one is missing. There used to be pink unicorns here. We're hoping for those to return because they are the best. Again, this is it's not an operational thing. You pick one that you like. It's just a visual pleasing thing. And then the other is actually something you might want to change. What the color looks like for the web shell. I just changed mine to the black on white because for projection it makes it a whole lot easier to see. I personally use the gray on black just because I tend to work in the dark and I like it that way. I don't like the glare of the screen. But that is a personal preference, but it is very much one that will affect how you work. So that's one that can be changed to how you like it. Then again, under Advanced, if you click there, you'll see a couple options that come up. The first one is deployment scripts, and that's not something that most people will use. However, you can put a shell script in here to do all sorts of things that will happen on boot for your instance. So you can have it create users, you can have it install software, repos. Anything you can do in a shell script, you can do in a deployment script. So that gives you the opportunity to basically come through and you can hit the plus button and you can either, you give it a name, you can say run on first boot, run every time. You can import it from a URL, so if you have it sitting in GitHub, for example, you could just get a GitHub script, or you could import by text where you can just literally paste it in. So this gives you a chance to customize things if you so choose. So we have some advanced folks that are doing that. It gives a lot of ways to customize. Like for instance, one of them is pulling in a container at every boot, and he wants it always to grab the latest container every time it comes up, which is great. So he doesn't have to worry about doing it. It's nothing that he couldn't do from the command line, this just automates it. So that's what deployment scripts are for. The more important one that a lot of people use is the SSH configuration. So people that are familiar with SSH keys, raise your hand. Okay, 2 out of 3? No, not familiar with SSH keys?
Nope.
Okay.
But I need to help people implement sometimes when they do these workshops.
Sure. So SSH keys give a nice, secure method of accessing a resource. There's actually a link here to learn more, which is always fun and interesting. So you can actually click that and learn more about SSH keys. But you could do everything in Atmosphere in the web shell or in the web browser. So you don't have to have an SSH key. You can launch a VM, you can use your VM, you can destroy your VM, all from within Atmosphere. So if you're not familiar with SSH keys and don't want to know about SSH keys, you don't need to know about SSH keys. So there's that. If you are a more advanced user or you're just more comfortable using a Mac terminal or PuTTY or something like that, then you can add an SSH key and be able to use it remotely that way. So it really is as simple as copy and paste. So it's assuming that you already have an SSH key and you give it a name and you literally just paste it in. And I'll show you on my account kind of what that looks like. So here I have 3 SSH keys. So I have one for my work laptop, I have one for my personal laptop, and then I have a general one that I use for development. So these are all there. These all get injected into every instance I launch every time. So that kind of gives you an idea of using that. And again, you don't have to use SSH keys. It's just if you want to have alternate methods for access. The last thing is personal access tokens, and we're not going to talk a whole lot about that. That's primarily for Atmosphere API users, which right now are about 3 people. So if you wanted to use the Atmosphere API, you would need a personal access token. You would have to talk to us anyway about getting one. So we would probably have a discussion at that point about what you're doing. But it is an option to use the Atmosphere API. So you could spin things up programmatically for Atmosphere. You could spin up 50 instances at a time if you wanted. You could delete 50 instances at a time. But it basically lets you do all the things you could do in the Atmosphere programmatically. So it is an option. It is there. It is not well used. So we're not going to spend a lot of time talking about how you use it. Any questions on the settings before we move forward? All right. So the next thing I want to do is click the Images button right at the top. So again, we come back to the image library. And we talked a little bit about this at the very beginning. So when you log in, you see this. But now you can actually see the whole thing and you can get a little more information. So the first thing you notice is there's an image search box, and then we have featured images. And featured images are ones that are maintained by the Jetstream team. So we provide these, we maintain them, we keep them updated. We provide these for people to build on and for people to use. So you can kind of see some different things going on here. Like the first one is a MATLAB minimal. This was actually built so trial users could try out MATLAB on a 2-core. You start seeing things like Ubuntu 18 development in Docker and CentOS 7.5 development and Ubuntu 16 development. These are more general images that people can build on. They have a lot of things that are built into them that people can use. Again, through Genomics Toolkit and a more specialized image. MATLAB, as we talked about before, R and RShiny, R with Intel. Basically different things that we maintain for users to use and build on. And then you scroll down and you see the all images. And this is everybody. So anybody that makes an image public will show up in all images. So for instance, this one is an IU researcher that has an image that he has specifically made public both for his lab, but also because he has shared it with the community. He has published papers telling people, if you want to try out our workflows, get an allocation on Jetstream, here's how you do it, here's our image. So there are people that do that as well, and it's actually a really nice way to do things. So people can use his workflow, they can reproduce his science, they can build on his science. But you see everybody sort of has come through and has started adding things of their own, which is exactly what we want. So here's an image that a particularly active lab at Brandeis has built. And to look at their information, so you can see when it was created, you can see who it was created by, and then they give it a description. So they basically in there have said when it was updated, they've said what they've done to it, and then in each version, you can kind of see their information here. So the initial version, you can see the things that, here's what they added to it, and they were very verbose about what they've added. And that's what we recommend as a best practice of, really, if you're going to make an image public, tell people what's there, and they might find use, they might use it further for themselves and then build on it, which is a great thing. It's how we make the community better. You can also see that it's available on both clouds. So we have a Jetstream TAC cloud and a Jetstream IU cloud. Something we touch on in the slides and the physical aspect of the machine. So this image is there on both of them. And that's really what you see from here. You can, at this point, you can favorite an image, so it will show up as a favorite when you go to launch. You can add it to a project. You can launch it right from here. But this kind of gives you the full information on an image that's in the image program, in the image library. One of the more interesting things is that you can also search. So we want to find all of the Jupyter-based instances or Jupyter-tagged instances, not Jupyter. So I search on there, and it brings up anything that has Jupyter either in the title or in the tags or in the text. So this one, for instance, there's the Jupyter tag, so it shows up in our search. This one actually has it in its title, but it's a nice way that if you want to find things quickly, you can search on it. And that actually brings us to one of the things that I did miss, is talking about the tags. So going back and looking at one of the images here, the tags are just metadata things that the image creator adds in. So this is one that some J. Fischer guy built, and these are all the tags he added to it. So that makes it so you can search on it, you can take a look at what's there. It's another way of making it findable. So we wanted to make sure that it was easily identifiable. Yes, it has MATLAB in its title, but let's tag it. Mathematics, so if people are looking for any mathematics related things, it is Ubuntu based, it is featured, it has Docker and Docker Compose built in. So I love the opinion that when you build an image that you give as much information as you possibly can in a very small space, so that way people know what they're using. So for instance, this tells you what's installed, this tells you the initial build, what's there and why it's there. So it's just a good practice to give people a lot of information on what the image is. Any questions on images? Hearing none, we'll move on then. So the next thing is click the projects button. And hopefully it comes up and says 0 projects. Is anybody not 0 projects? Well, you're using your own account, it doesn't matter. The training accounts, these all have to be cleaned out manually, unfortunately. So the person who cleans them out doesn't always get everything. He tries really, really hard. So projects in the atmosphere sense are logical containers for your work. These are things that you define, that you give a name to, that you give the metadata to. They are arbitrary. You can have 1, you can have 10. It's really up to you and how you use the system, what your workflow is. I know people that are doing multiple research projects, so they have a project for each research project they're doing. That way they keep their VMs separate and they don't have to worry about which one they're in. They can look at their project and know exactly what they're working on. So it really comes down to a personal thing. I personally tend to use one project because everything I work on is ostensibly for Jetstream in some shape or form. So everything of mine sits in one. It's just entirely personal preference. But we're going to create a new project. So we create the new project button. We're going to give it a name. We're going to say UC October 31 project. And you can call it anything you want. I do think it's a best practice being very descriptive about what you're going to use it for. So if this were going to be a biology, a genomics project for a specific workflow, I would put that in the description. So, this is a project for a workshop on atmosphere at UC on October 31. And then hit create. And you should see that come up. So you should see that come up. And the interesting thing you see, so you see the title, you see the description we gave it, but you also see down here at a glance, you can see the instances, you can see the volumes, you can see any images that you favorited, and then you can see any links. Links I don't exactly understand why they're there because they're essentially bookmarks, but it's built into the UI, so you can put favorited links there as well. But let's go ahead and click into our project. And hopefully you see something along this line so you don't have instances or volumes or images at this point. And right now we're going to start getting into the fun stuff. So we're going to click New and click Instance, and this is going to let us create our first instance. So the first thing that comes up is you see our image list comes up. Now there's a couple things that happen. Show featured, show favorites. So if you start any of them, you'll see them in this list, and then show all. You can also search. So if I just wanted to see, I'm seeing featured, but if I just wanted to see CentOS featured, I can search there, and it's going to bring those up. So these are only the CentOS featured VMs, or things that say CentOS. I don't know why that Ubuntu one is there, but we're going to take that one out. For the sake of fun and whatnot, we're going to launch the CentOS 7 Devel with Anaconda. You can pick any one you want. This is the one I'm going to launch. So the first thing you see is the instance name. Were you able to get there, Amy? You're making faces.
Yeah, I got it.
Doing wrong my button. Okay. So you've got this screen? Cool. All right, so the first thing you see is the instance name. Now you can set the name. You can see it's already pre-filled in. If you don't give it any other name, it just takes the name of the image. As a best practice, I always recommend giving it a descriptive name, even if you do leave some of that in as part of the name, because what I've seen more than once in trying to help somebody out, that they've launched 10 instances and they're all named Ubuntu 18 Devel Docker. And so when you say, well, which one's having the problem, they're like, I don't know. It always makes it best to say, this is going to be our UC test 1. And I put that in front of it, or you can completely change it. You can call it Bob. It's entirely arbitrary. What you want to call it is up to you. I just think as a best practice, giving it a descriptive name so you can find it later is a good idea. The next thing you see is the image-based version. Now there's 2 versions available of this particular image. Unless there is a compelling reason, always launch the latest version. The only time I've ever run into where I needed to launch a previous version is if I introduced a problem in an image that I created and needed to go back and do the last one. The next thing is the project. Since we only had the one project, that's the only thing listed. If you had multiple projects, you'd see all the projects listed there and you could choose which one you wanted to put it in. Again, with the allocation resource, the same thing. We only have the one allocation for the training accounts, but if you have multiple allocations, you can see them all there. And this is what they bill to. And I'm using my quotey fingers for that. Because again, there's no money involved, but it's all in your allocation spending, the number of core hours that you use. So if you have multiple allocations and one is for a particular researcher and you're doing their research, make sure you put it in that one, because if you burn somebody else's allocation on unrelated things, they may not be too happy about it. You can pick which cloud you want to run on. I'm particularly partial to the IU cloud because they are my employer. It really doesn't matter. The only thing that's going to matter is in terms of volumes, and we're going to touch on that a little bit down the road here, but you can't use volumes across clouds. So if you have a volume at IU, you can only use it with instances at IU. If you have a volume at TAC, only with instances at TAC. So that's the only thing that really matters in the grand scheme of things about which provider you choose. Like I said, I'm going to use IU just because it's near and dear. The instance size typically goes from M1 tiny up to M1 extra large. You notice we don't have a tiny option here. It's because Atmosphere knows that this particular instance is too large to run on a tiny, so it's taken that option out. I'm going to launch it on an M1 small. And that shows, again, 2 cores, 4 gigs of RAM, 20 gigs of disk. It shows the allocation we've used to date. It shows what the resources will be when we launch this. So if we're going to pull two cores in of our allotment of 132 and 4 gigs of our 360 gig RAM. So that said, hit the launch key, and it's gonna do its thing. So it's launching. That'll spin until it's gotten an answer back from the cloud on where it's going to go and when it starts building. So bear with me a minute. We'll talk a little bit about instance size. So the first thing that happens inevitably when people get Jetstream access is the first thing they do is they launch a 44 core. It's 44 cores, it's got the most cores, it must be the best, right? Right. So everybody inevitably does that. And there's reasons to use 44 cores, there's reasons not to. It burns up more of your allocation faster, but if you need 44 cores, by all means use 44 cores. If you don't, it's better for both your research and for the economy of your allocation to use what you need. And sometimes that's the trial and error process of figuring out what you need, but we've found over the years that having more cores doesn't necessarily mean better performance. So try things out. It may take a few go-arounds to figure out what the optimal size you need is, and then run with that. So it's just one of those things. It is inevitable. Everybody tries a 44 core first thing. Bigger must be better, right? So you can see I've gone to build scheduling. So it's talking to the cloud right now, and it's trying to get a place to schedule my VM, to put my VM. That should hopefully refresh in a minute. We'll see it into active. I'm going to force a refresh. I'm still in build scheduling. Everybody build scheduling? Are you active initializing?
Yes.
Excellent. Yeah. We'll talk about what those mean here in a second. Did you go on the IU cloud or on TAC cloud?
IU.
No. Fascinating. I'm behind the times then.
On your allocations where it shows how much you've used, that happens until you shelve them. It'll take up more and more of your allocation until you shelve them.
Yeah, when you shelve them, it should remove those from your used resources. Stopping and suspending do not. Oh, there we go. We're in active networking. So the different things that are going on here, you notice it says active, but it's yellow. So active in this case is really not active as in usable yet. It is, the VM is active, but it's still doing some things behind the scenes. So from an OpenStack point of view, this machine is booted. If we went in and actually looked at it, we would see it at a command prompt. In fact, we're going to do that while we're waiting. So we're going to do some secret sauce here. I'm going to grab the UID and kind of show you what's going on. So this is what we can see from the other side of the world. So we can take a look and see if it comes back. Okay, there we go. OpenStack, as far as it's concerned, this is running. It's got its IP and everything. And I'm going to show you the actual boot log. So if it were hooked up to a physical monitor, I mean, it's a VM, so you can't really do that. But if it were hooked up to a monitor, this is what you'd see. And the interesting thing is we are booted. You can see it's installed some updates. If we scroll back a little bit, you notice right here, we have a boot prompt. We have a login prompt. So as far as OpenStack is concerned, this machine is up. It is booted. It's a live machine. It's a little different from the Atmosphere side, and I'm going to tell you why about that. So right now we're in active networking. So what it's doing underneath the scenes is it's building a network for you. It's getting a real public IP, so that is a real honest to God IP that you can get to from the rest of the world. It's not behind a VPN. It's not shielded that way, so you can use it. You can get to it from anywhere. But the other things that are happening, you'll see it go into active deploying here in a few minutes. And that's where Atmosphere is doing a bunch of things that you don't get with OpenStack typically. So what Atmosphere is going to be doing when it hits the deploying stage is installing a bunch of software. It's going to be injecting SSH keys if you put them into Atmosphere. It's going to go through and basically try to make it a better environment to use. So it's going to install the things you need to have for the web shell. It's going to install the things that you need to have for the web desktop. It's going to go through and install things like Failovan to help protect you. We're patched up to date. It's going to put a few other things in to make a better usable experience. That's why it takes a little longer for things to run, to boot. From the OpenStack side, if you boot an instance, you can typically log into it in about a minute. From the Atmosphere side, I tell people 5 to 7 minutes is a typical boot time. And it is a little longer than we would like it to be. We're working on getting that trimmed down a little bit. But again, there's so many things that are going on behind the scenes that it's kind of hard to do that. We're still in active networking. So it's still doing its thing. Yeah, we run cloud init. We're getting there. And this is the part of the presentation where I wander around going, well, this hurry up. Hey, we've gone to active deploying. Are you guys still active deploying, or have you gone active?
I'm active.
You're green?
Yep.
Well, I just green Travis Lee. You active? Okay. So Amy's the winner today. I don't know what you win, but you're a winner. She'll write 2 pages of your dissertation for you.
Oh, that's good. Good prize.
In the meantime, while we're waiting for this to happen, are there any questions to this point? There are no bad questions, just bad instructors. All right. I won't beat on you too much. So we'll let the video guys edit out the waiting portion of this. Yeah, we're at 6 minutes. We should be hitting active very shortly. I did a tutorial on Monday, and for whatever reason, the TAC cloud was taking like 11 to 12 minutes to boot, and we don't really have any idea why. It's not. You're both active? Great, I'm Slowpoke. Awesome. Yeah, the funnier thing with the one I did Monday was there were 2 or 3 people that would never go to active, so I finally was like, okay, I'm tired of waiting, I'm going to go look and see what's going on. So I went to their machines, and literally, I touched the machine and refreshed, it was active. It's like, it just wanted me there. It missed me. So when that goes active, we'll do the rest of our fun stuff. I really swear I saw lightning a minute ago, but I could have just imagined that.
I mean, it's pretty cool.
Thank you for graciously being a guinea pig, by the way. I just heard my mail ding, so that was probably my active mail, so this is probably going to be in moments. Or another moment or two. Of course, it's me that everybody's waiting on. It's not my fault, I swear. There we go, just went active. Hooray. All right, so now that we're active, I'm going to again talk about some things on the screen here. So again, green active. So you can only use your VM when it is green. If it says active initializing or active deploying, we can't guarantee that you'll actually be able to get in and use it, especially on a newly launched instance. Activity showing not available, that just means that there's no other state for it to show. So you notice that said initializing or deploying when it was doing other things. This just means that we're active and there's no other state to be reported. It tells you the size, it gives you the live IP address, when it was launched, what image you're using, what provider you're on, and then there are two IDs at the bottom. So one is just ID. That is the atmosphere ID, so that's what it refers to. And if you actually look at the URL, you see that it is instance 28107, so that's the actual URL that gets built onto it. This horrible long string that you notice that I copied to look at things behind the scenes, this is the UUID. So this is a unique identifier that OpenStack assigns to every single instance, volume, network, whatever. Everything that OpenStack deals with gets one of these horrible UUID strings. It is a unique identifier. It can always be used to identify whatever resource you need to look at from the OpenStack side. So if the day comes that you have to report a problem, we're going to want to make sure we have that UUID so we can go through and look at it. The other interesting thing is down here at the bottom, you see the instance status history. So we can come in and quickly see, when it was built and then what's happened to it along the way. So we can see when it was in deploying, when it was in networking, when it was back in deploying. We can see if you rebooted, we can see when you stopped it, shelved. And we can see all this from behind the scenes as well, but it's nice to have it here so you can see at a glance what's happened. So some of the different things, great, I just lost my place, bear with me 1 second. So you see that we got some buttons here over on the side. We're going to talk about all these buttons, all the actions and everything else. We're going to come back to report an image, but we talked at the beginning about suspend, shelve, and stop. So those are your options there. So again, suspend, you can close up your laptop. Stop, you can power it down. Shelve, you can power it down, remove all connections, put it away. So those are the management options. And then once you suspend, stop, or shelve, you have the converse, start, unsuspend, or start, resume, or unshelve if it's in one of those states. We're not actually going to do those right now. The other two things you see are reboot, and redeploy. So the difference between the two, redeploy is an atmosphere-specific thing. So you notice how we were in active deploy. If you've done something like you've installed a new SSH key into your settings and you want it to be installed on an active instance, if you hit redeploy, it'll go through the deployment phase again, and one of the things it'll do is it'll shoot your SSH keys in. So if you've added an SSH key after you've booted an instance, you can go back through and redeploy and it'll do that. Sometimes, occasionally, VMs get stuck in deploying. So if it's been in deploying for more than, say, 5 or 10 minutes, sometimes redeploying will help. Typically what happens in that case is it's doing updates and the updates are coming. And that happens sometimes. So redeploy is a nice option that you can use if needed. If your VM has not booted and if you've hit a 10-minute boot point and you had to come up, I always say hit a redeploy, wait another 5 minutes, and if that hasn't happened, then you do a reboot. And a reboot comes in two forms. Now we're going to hit the button, but do not actually tell it to go. So this kind of tells you what's going on. It'll shut it down, it'll become accessible. It's literally like booting your laptop. There's a soft reboot and a hard reboot. And a soft reboot is an ACPI restart. And what that is it's a power restart. There's a protocol that basically says, turn off the power and turn it back on. And that's considered a soft reboot. It's gentle, the system expects it, it sees that call, it shuts everything down. The hard reboot is literally, you are yanking the power cord out in the middle of doing stuff. So it's not graceful. Sometimes you have to do it. If things get truly stuck, and I've had it happen before, where things get truly stuck, you have to do a hard reboot. We always recommend a soft reboot first. There's 1 or 2 cases where that is not the case. But when that happens, you'll probably be in communication with us and support anyway. So it's just a good rule of thumb that a soft reboot is always a good place to start. The next thing you see is the big red delete key. don't use that unless you really, really mean it. We're going to use that at the end. But for now, just know that it's there. It's going to ask you before you hit the go button whether you really, really want to do that. But if you go further down the screen here, you're going to see under the links area a few things. There's the old web shell and the old web desktop. These are legacy. They're still there. I do not recommend using them because they are fraught with a little bit of peril. It's what we used when the system initially rolled out for doing web shell and web desktop. They still work, but they're a little more buggy than we would like. We leave those there mostly for troubleshooting purposes. Eventually those will disappear. But for now, what we want to do is hit Open Web Shell. And this will do exactly what it describes. So it is opening a Unix shell inside your web browser. So you should get something that looks something like this. It'll say atmosphere, it'll have a command prompt. This is a Unix shell, just like any other Unix shell. This is typically where I'd ask how many people are Unix users or at least familiar with Unix in here. And I'm expecting 2 out of 3 hands to raise. Okay, one out of 3 hands raised. It's okay.
I'm running behind you.
Oh, okay. Sorry. So at this shell, it's just like any other Unix device. You can get a directory listing. You can see anything. You can treat it just like you would if you were using a PuTTY client or a Mac terminal with SSH to get in. You can do anything you want from here that you could on any other Unix system. Now the interesting thing is when you do this. So I've now done sudo su dash, and you notice my username changed from train52 to root. So for those not familiar with the Unix way of life, I now have root access. I have super user powers. I can install anything, manage anything on the system. I can also briefly shoot myself in the foot. This is actually where I tell people I have stood over somebody's shoulder before in one of these and watched them get root and be messing around a little bit, and then I literally watched somebody type rm-rf/. And of course, that does a recursive delete of the root file system. At which point their VM went, and they said, oh, how do I fix that? You don't. You've now undercut your system and it's dead. So it's very much the Spider-Man thing. With great power comes great responsibility. You got root, you can do anything you want on it. Just think about what you're doing before you do it. The safer thing to do a lot of times is if you want to just do a root action is I want to say, I want to touch or create a file in the root file system, we'll call it foo. So now, if I look, I should have a file called foo, and there it is. And that's typically not something I can do as an unprivileged user. But now, by doing a sudo command, I've now been able to say, super user do that. And so that's a safer way to one command shot instead of being as a root user shell. So you can, at this point, you can install anything you want. Typically, one of the first things I do, because I'm a system admin by nature, is say sudo yum update. So this is just the best practice of going, am I up to date? I am up to date. One of the nice things about booting on the IU cloud is you get forced up to date every time. So, but anyway, it's a good habit of being always making sure you're up to date. You can add repos, you can add containers, you can add other software, you can bring in your GitHub stuff if you need to. You have every capability at this point. You can also do that as yourself to some degree. So that is the web shell. So go ahead and type exit here, and you should get a disconnected notice, and we're going to say log out, and it goes back to a nice little Jetstream screen. We're going to close that tab, and we're back at our instance. The next thing we want to do is say open web desktop. So a little different from the web shell is the web desktop. So this is literally the desktop you would see if you were sitting in front of it. I'm going to change my resolution a little bit, make it a little nicer. But you can have a nice GUI interface. If you prefer a GUI interface, you can have that here. I'm going to launch the Anaconda Explorer just to kind of show something here. But again, this is literally just a normal desktop as if you were sitting in front of it. So So if you're more inclined to using a GUI environment, it is there for you. Bear with me 1 second. You can also launch a web browser. Since I'm on a 2-core, it's a little pokey at the moment because this is a particularly robust image. I probably should have launched this on a larger one. But I've launched my web browser, and it's coming up to the Jetstream wiki, which is where we have all our documentation, which I'll talk about that at the end. And then here's the Anaconda Navigator. And this is just a nice little bit of software. Since Jupyter is a very popular thing these days, this is an image I created to make it a whole lot easier for people to come in. They can launch Jupyter Lab, they can launch Jupyter Notebooks from here. They can install their own Anaconda applications, but it gives a nice way to do that. This just is to demonstrate the GUI interface on Jetstream. So we're not actually going to use any of this. That's a tutorial for another day. But it's just to demonstrate this is just like any other desktop GUI. Are there any questions before we get into the fun parts of the desktop GUI? Okay, Amy's going to be leading this part. So you notice down here there's this little thing that says attention to copy and paste or upload, download, use Control-Alt-Shift. So there's the thing that's going on there is something I never thought about in our initial use of Jetstream. The reason you have to go through an alternate step to be able to copy and paste, and so, hello. There we go. So to be able to copy and paste, you have to pop out this window, copy something into there, put the shelf away, and then copy it into your window. The reason behind that is one I'd never thought about. It's actually a security thing. So if you give somebody access to your cut and paste buffer in your browser, they can do all sorts of bad things to you. And I never really thought about that before, but a web developer is like, well, if you now let somebody arbitrarily take things from your computer or put things into your computer, you've now given them a lot more control than you probably intended to. And it's something I never thought about. So because of that, that's why we have this two-step system for the web shell and the web desktop that nobody particularly likes, but I get it. So if you need to copy and paste, following that little tab down at the bottom, and we cover this in the wiki as well, is going to be something you have to do. But the other thing that's nice in here is you can also transfer files. So if you look at, you see this little disk, it says devices, you can actually click on it, and it brings up an upload files window. Now you can only upload to places you have, sorry, you have a problem in the shelf. Okay. It's all right. So you can only upload to places you have write permission to. So I'm going to write into our home directory, and I'm going to say upload a file. And so I'm going to grab, this happens to be a hotel bill. Oops, hello. Oops, sorry. It is trying to upload that file now, but what's happened is I've actually been disconnected. I think we just lost network. Nope, there we go. I'm on edgy roam, so it drops from time to time. Okay, so let's see if that actually went anywhere. Okay, my transfer didn't actually happen, so let's try it again. So home, train 52, I'm going to say upload file, I'm going to grab this PDF, and you can see it's transferring. So that is actually uploading into my directory right now. Let's see if it's there. Poof, there it is. That's really hard to read. Wow, that is really hard to read here. That's the file, I can see it on mine. But that gives you a way that you can upload files via the web shell. Again, you don't have to have a third-party client to be able to get things in and out of Jetstream. All right, other questions? Well, as your user, you'll always have access to your home directory. So if you go into home and then whatever your username is, you can write in there. You can write into temp. I think that's probably it by default. Other questions? All right, if not, then The polite way to leave the web shell is again to bring out the tab and hit disconnect. You can also just close the tab in your browser if you really want to. It's not going to do anything bad to it, but it's just a polite way to tell it I'm done. So we're going to talk a little bit about volumes now too. So let's go back in and click the project. So we come back here and we go into our project. So here's our instance. But let's go in and actually hit the new button and hit volume. So that's going to pop up another screen like we saw before. It's a little simpler than we saw before, where we're going to give it a volume name. So we're going to call it UC test volume 1. And we're going to give it a size. I'm going to make it be 10 gig. Now if you watch the little slider down at the bottom and I say 100 gig, it's going to say, oh, you're going to use all of it. It's dynamic and kind of shows you what your usage is going to be as you go. So that's kind of a nice thing to keep you from getting frustrated by pressing the button and going, oh, you don't have space to do that. The other thing is you can set your provider. And again, as I noted before, you can't mount volumes across clouds. So if your instance is on IU, make your volume at IU. Mine is. And then hit create volume. And it's doing its thing. It's saying creating. It's going to pop back here.
If your volume is on IU, you will still have your choice. Like, your volume is on tap, you're going to still have those choices.
Yes.
It just doesn't.
Yeah. It doesn't know where your instances are yet. It just tells you, here are your options. Because eventually there will be more options. Maybe not today, maybe not tomorrow, but soon for the rest of your life. So now you should see your volume here. It should say unattached. Everybody see volume unattached? Okay. Go ahead and click back into your volume. And you see the buttons we have here, report, attach, and delete. Report we're going to cover here in a few minutes, which is the same thing as the report for the instance. But let's click attach. So it's going to bring up a dialog box. This would be a drop box where you can attach it if you had multiple instances. We just have the one. So we're going to attach it to that one and say attach to volume. Attach volume to instance. And so you'll see it come back here and it's doing its normal thing, attaching. And it should take not too long. So what's going on behind the scenes here are a few things. So when you create a volume, typically in OpenStack, when you create a volume, all you say is, give me this amount of disk space. It doesn't do anything else. Atmosphere goes a little further, which is why it takes a little longer. And it says, give me this amount of space, put a file system on it. In this case, it's Linux ext4. And then in this case, it's saying, attach it to that instance and then mount it. In OpenStack, it only attaches, it does not actually do the mount. So you should see it now attached to your instance. Everybody good? Oh, great, okay. Which train are you? 51, okay. Bear with me 1 second, we're going to fix that. So here's another fun thing that I can do. I'm now you. It will be you in a second. So I'm now train 51. There's your spooky project.
And the monster.
Okay. And now you should be available again. Oh, there you go, unattached. So try to attach again. Did it go this side? Attached, yay. Cool. All right. So everybody's volume is attached now. So now let's go back, click resources up here. And you're back to the screen where you can see everything. Let's go back to our instance. And let's go into the web shell again. There we go. Okay. So if I look in slash, if I look at my root directory, I see now a volume called volb. And you can verify that things are mounted by doing a little Unix command here called df-8. So this is actually disk-free, human-readable format. And here's volb, 9.2 gigs available out of 9.8 gigs, so 10 gig volume. So you can see it is attached there. We can actually say, touch volb foo and create a file on volb. Come on. There we go. So now we have our file that's created on volume B. You can use this like any other attached hard drive. You can write things there. You can delete things from there. You can do anything you need to do using that volume. That's your persistent storage. That's where you want to save the results from your research runs, things like that. So that gives you a nice place to work. Mounted volumes on Atmosphere will always be vol something. Will always be vol B, C, D, E. Vol A is actually reserved. A is actually the boot drive. So if you look for slash, it's dev SDA. So that's where it actually takes its letter from. But every mounted volume will always end up being slash vol something. So you'll be able to spot them easily, and you can always find them doing a disk free. Any questions on using volumes? So one gotcha is that whenever you disconnect and you're not going to want to use a volume anymore, of making sure that nothing is using the volume. So I'm making sure that I'm not in my volume directory. So I'm not in slash volb. And if I want to be really sure, this is me being the sysadmin type that I am. I can look and say, is anything actually using volb? And there's actually a reason for doing that, because if anything is using volb, if you're running a process out of there or saving something through there, you won't be able to disconnect it. So we want to make sure nothing's actually using it. So we're going to go ahead and exit out of our session, so you can type exit or log out. And here we are again at our nice screen. We're going to go back into resources. We're going to go into our volume, and we're going to say detach. And because yours went to reserved before, I fully expect it to go to reserved again. It happens sometimes. That's.
So what does reserved mean?
So reserved is an OpenStack state, basically saying that the system has reserved it for use. It is a valid state. Atmosphere, unfortunately, doesn't know how to deal with it because that's a relatively new development. So we're working on having that be fixed. You can use a reserved volume, but Atmosphere doesn't know how to address it yet. So we're getting them to add that. Let's see how many of these went this time.
So if we do get into reserve, we have to contact the support?
Oh, yep, it's a reserve. Yeah, we have to undo it for you. Amy's went into reserved again, so I'm going to undo it. Once it goes into reserve, it seems to happen again. Okay, Amy's now detached, or unattached. Okay, so let me go back to, and let's go ahead and delete our volumes. So, click delete. Yes, delete this volume. So the question that inevitably comes up is, for volumes and instances, how are backups handled? And my answer is however you would like them to be handled. Jetstream does not do any backups, and there's an obvious reason for that. Backup servers expect to know what resources are there, and since VMs on Jetstream come and go at will, we have no idea what's there. So we don't back up your information. That's why we always recommend putting things on volumes, and we recommend multiple copies of things. You are responsible for your own backup strategy. It's very important. You don't want to be the first person to lose your data. Are there any questions up to this point? Okay. All right, so we've deleted our volume. We're now going to do the next thing that I call cleaning up, and we're going to delete our instance. Oh, actually, wait. Sorry, I missed the two buttons up here. Very important thing. So report. If you click the report button, do not click submit on this, please, because it opens a ticket. this will say, I want to report a problem on this instance. It will actually give you links to troubleshooting if you need to first, if you want to check there first. You can tell it what sort of problem you're having. You can give us some information about it and then report it. And this actually sends us that information, but also gives us a UUID and your username and gives us information so we can go through and troubleshoot you. So if you need to report a problem, this is the best way to do it, because that way we get all of the information to do it in one swoop, and you're going to get a better response faster. So we're going to hit cancel there because we're not going to submit a ticket. But the other thing, and we talked about this a little bit, and we would have talked about it more in the slides, but requesting an image. So one of the reasons to use Jetstream is to have your own custom workflows. So you don't have to recreate them every time. You can create the workflow you want. You now created your image that you can watch again and again and again and again. This is the process that gets you there. So when you click that image button on an instance, so you've used that instance, you've installed everything you need to have installed. There's some caveats to that you can't install in your home directory and a couple other places. It's in the documentation because those get wiped as for security reasons when you go. That actually has a link here to go to the wiki page about getting that information. But you've installed everything you need, and you're ready to create a custom image. So you would give it a new image name, and again, I recommend as a best practice to give it a descriptive name. So, Ubuntu 18 for Amy's dissertation, and then in the description put whatever information, whatever you've installed there, whatever makes it unique and different, whatever people are going to need to know they can run. Give it tags. So I'm going to fill in some of these things. We're not going to submit it because also this opens a ticket and actually starts a imaging job. So we're going to say test image from UC. So that's our descriptive name, October 31. Ultra spooky. Other things, whatever. And then we'll give it our tag. So this is a CentOS instance. It's mathematics, just because I know that that's there. It's bioinformatics, whatever. We give it a version name. Now this again is a best practice. This is for you, and this is also the versioning that goes into the image library. So on a new image, I always give it 1.0, and then the next one I'll do 1.1 or 2.0, depending. It's really up to you. But give it a version, and then in the changelog, this is again in your best interest and a best practice to be descriptive. So initial install, added foo, added bar, added stuff, whatever. Tell all the things that you've done to it, so that way you can go back and look and see what you've done. It's just a good idea. And you can say next. So this is the image visibility that we talked a little bit about. So public, everybody can see it. Everybody that uses Jetstream can see it. Private, only you can see it. And then specific users, you can name the users that you want to see it. So people in your lab, people in your work group, other people that you are collaborating with. You can do that. And then you can hit submit, which we're not going to do. And it will create a, did you hit submit? Okay. You just had that devilish look about you. Yeah. I'll know in a minute if you did. I'll get an email.
It's like all your name is in here.
Oh, I'll know where it came from. So when you submit that, it goes to a ticket's created, a job is created, and we actually run it on the backside of the world. In fact, let's just go see if there's any images waiting to be done. So I'm going to go in as me, and I have a few more options in the grand scheme of things than most people get. So let's see if Amy's been devilish. Bear with me 1 second. Come on. You're going to see what an image request looks like from the CD underbelly of Jetstream. So I'm going to click my admin tab and imaging requests. And Amy did not submit one. But you can see, like, for one that I submitted for a featured image, you can see, you saw the MATLAB minimal instance. And this is where it was actually built. So this is what we see from our side of the world. So we see everything here, and we verify the information, make sure everything looks good, and then we tell it approve, and it starts building. So That's just kind of the seedy underbelly of Jetstream. So we've covered all the buttons here. Are there any questions about the instances or any of the functions or how to use it before we take the last couple steps? Good? Okay. Well, we're going to do what I like to call cleaning up and hit the delete button on your instance. And it's going to say, warning, data will be lost. It's really not kidding. Once you hit that go button of delete this instance, there's literally like a second that we have to stop it from happening. So by the time you say, hey, I don't want to do that, it's gone. So be sure you want to delete it before you delete it, because there is literally no recovery. It's once you hit go, it's gone. We do want to delete these, so I'm going to say go. And it's going to say deleting, and it's going to walk through its thing. It should refresh itself in a moment. We've now deleted our instance. I'm going to force a refresh just because I'm curious. Network is a little laggy for me anyway. I'm on edge of Rome here, so I'm a third class citizen. Yeah. Okay, so you can see our instance is gone. The next thing I want to do is actually delete our project. So go to Options and Delete Project. And say yes. And we should be back to 0 projects. Any issues so far? Okay, there's 2 things I want to hit. And those are watching things and not you actually participating things. So the first thing, the most important thing, actually, let's do the less important thing first. So we're going to go to our Jetstream website. So this is just the public website. And I'm going to show you that a couple things. So one is citing Jetstream. So any work that is done on Jetstream, we do ask you to cite us if you write papers. So we have those on our website. And everybody that gets an allocation now, I make sure and include that in our review. But the other thing is also under support. There's a thing called DOI requests. So you created a custom VM. You've done your work on it. You've published some papers. And now you want to make that available as part of one of your publications to let people know that it's there. You can actually submit a DOI request for your Jetstream VM. And it's like getting a DOI on any other publication. So you can say, give the metadata, who are the authors, you can list you and all your co-authors. You can give it the title, all the normal metadata you would give for any other publication, keywords, and then, description, who's funding it. And then you can tell us the UID or the name of the image, and then we'll go get it. And what's going to happen with that is actually you're going to end up in ScholarWorks. So ScholarWorks is the IU repository. This is our HPSS system. Things here are meant to last into perpetuity. Our president has committed to funding this for the foreseeable future. So I'm going to say search for Jeremy Fischer because I happen to have a couple things in here. So here is one of our test images. So we've submitted this for DOI. It'll come in here. There's our handle address, which is our ScholarWorks address. But here's the DOI that we can actually use to publish with. So we can cite this in a paper and put a DOI in there, and anybody can then use that DOI and it'll end up here. This link has actually been removed, but typically you would click that and you could download the image and you could take it to your own cloud, you could run it on VirtualBox, but you have the ability to recreate somebody's work that they published using the DOI. So that's a function that's there. And it just makes it easy that if you do want to share out work with other people, you can publish it and easily refer to it. The other thing I wanted to show you, though, however, is the most important thing, and that's the Jetstream Wiki. So you've noticed that it's wiki.jetstream-cloud.org. That rewrites to a really horrible URL, but this is all of the most up-to-date information on using Jetstream. So it has everything from getting allocations, and this has a step-by-step walkthrough, to information about virtual machines. Basically, everything you might need to know about using Jetstream should be here. This is the site that we live by and we try to keep up to date. And if there's something missing from it, please do feel free to let us know. Other questions, other thoughts? Anything that I haven't covered that you wish I had covered? All right. Well, I want to thank you all for being my guinea pigs today and doing the Jetstream tutorial. If you have questions, you can always come to us via the help at Exceed email address we'll get to us. You can always check the wiki for more information, but we hope to see you on Jetstream, and if there's anything we can help you with, let us know. Thank you.
Now, if we get a faculty member who wants to use Jetstream, their first step should be to apply for an allocation from Exceed.
I would suggest getting a startup allocation, yes. The startup allocation is meant for exploration, so if they want to see if Jetstream will work for them, that's where we recommend going. They can get 50,000 to 100,000 core hours without blinking. All we really want to know from them is a paragraph on what they intend to do. And that's it. It's a really simple process. That wiki page literally walks them through step by step of the first steps are getting an Exceed portal account, and it walks you through those steps, and then the next steps are applying for a Jetstream allocation, and it tells you exactly what we need. So it hopefully reduces any ambiguity. Typically, if somebody's following that process, it takes about 5 to 10 minutes to get the Exceed account, and then about 5 to 10 minutes to get an allocation. So they can have that done in under a half hour. They'll typically get a response back within 1 to 2 business days. So if they did it on Monday, they'd have an allocation before the week's out and could be using it. Good question. Other questions, thoughts? All right. Well, thank you all.